Chapter 14, Question 3 asks you to give the IUPAC name for the following carboxylic acids. And the first one they give you is this one. There are no branches here, and so we're going to get the prefix. We'll just name this as without branches, we get the prefix. There are 2 carbons, 1 and 2, so the prefix is going to be F. Then between those carbons, and we are just looking between the carbons, anything outside of carbons would be in a functional group, which would be represented in the suffix. So when we're looking for the infix, we just look between carbons. We can see that there are all single bonds between carbons, and so the infix is AN. Last but not least, if you look at the molecule, you'll see that there is a functional group. You know that because there are elements other than carbon and hydrogen here, and you would recognize that this functional group here is a carboxylic acid, and so the suffix is going to be oic acid. Now, carboxylic acids are always on the end of chains. If you notice, it has a carbon double bonded to oxygen, single bonded to OH. Carbon can only have a total of 4 bonds, so this carbon here already has 3 in the functional group. It only has 1 left to connect it to a chain. So it's always going to be at the end of a chain, and so you're always going to number that chain from the carboxylic acid, giving the carboxylic acid a number 1. So you don't have to say where a carboxylic acid is. You don't have to give a number for it. So the name for this molecule would be ethanoic acid. That's the IUPAC name. There's also a common name for this, and that's acetic acid. This is the molecule, the carboxylic acid that's found in vinegar. But acetic acid is a historical name, comes from the Latin word for vinegar, whereas ethanoic acid is the IUPAC name. It comes from the rules that were developed by the International Union of Pure and Applied Chemistry that are summarized in this table at the right. So that's A. All right, let's try to name this one. And they want to give the IUPAC name for this. Now, what should stand out when you first see this is that there is a ring with alternating single and double bonds. Let me just write that up here. If you ever see a ring with alternating single and double bonds, you know that that is a special molecule with special behavior. It's called benzene. And when there are functional groups on benzene, those functional group with benzene, that combination gets a common name and acts as a backbone all by itself. So if you ever had a carboxylic acid coming off of benzene, that would be benzoic acid. That's the name of that molecule. So if you ever have a carboxylic acid coming off of benzene, the parent chain is going to be benzoic acid. So here, the parent chain, I'm going to circle it, would be this right here. And the name for that parent chain is benzoic acid. There's no way anyone would know that unless they had memorized it. This is a common name given to a derivative of benzene. So benzoic acid. Now, we have branches coming off this, so you want to number this, and we're going to number it. You always start numbering these benzene derivatives from the carbon that has the functional group on it. So the carboxylic acid attaches here, where I just wrote that green 1. To get the lowest numbers, we would go counterclockwise. Now you can see our first branch comes off of carbon 2, so this will be 2, and it's a halogen. The halogens have the first syllable and then an O. So this is bromine and then an O. So 2-bromo. Then our next branch comes off of carbon 4. Again, first syllable, brome, and then an O because it's a halogen. The halogens are in group 7A, column 7A on the periodic table. Going down, it's fluorine, chlorine, bromine, iodine. So with all of those, you write the first syllable, then an O. Because these are both the same type of branch, they're both bromo branches, we can smush them together. Take the 2 numbers and put a comma in between them, so 2, 4. Always between numbers and letters goes a dash. Then you have to say how many branches you smush together, so di here, and then what type of branch, so the bromo. So we have 2,4-dibromo benzoic acid. Always put the name of the branches in front of that backbone name. Oops. In front of the backbone name. Whoa. And that gives you the overall name. So this one is 2,4-dibromobenzoic acid. All right. This one has a branch, so we'll try to find out the parent chain. The parent chain is the longest straight chain you can find without lifting up your pencil or going backwards, but it always has to include the functional group. So it's the longest chain you can find that includes the functional group. Now here our functional group is on the right, so we'll start looking there. We could have 1, 2, 3, 4, 5. That's one possibility. We could have 1, 2, 3, 4, 5. That's another possibility. Looks like the longest chain we can find is 5. And we have 2 that tie, so it doesn't matter which one we choose. I'm just going to go with the green one. And so I'll circle this. This is our backbone. So let's try to name that all by itself as if there were no branches on it. Then we'll worry about the branch. So there are 5 carbons. The prefix for having 5 carbons is pent. Between those carbons, just between the carbons, not anywhere else, it's all single bonds. And again, we're only looking between the carbons. Any bonds to other elements would be represented in a functional group in the suffix. So here, it's all single bonds between carbons, so the infix is AN. And last but not least, we have a functional group here on the side, carbon double bonded to oxygen, single bonded to OH. That's the carboxylic acid, so the suffix is oic acid. So the backbone name is going to be pentanoic acid. And you don't have to give a number for where the carboxylic acid is. It's always on carbon number 1. So we already know we have the backbone, and we already have the backbone chain numbered. So now let's think about the branch. We have a branch coming off of carbon 4. Always between numbers and letters goes a dash. In the branch, there is just 1 carbon. And so the prefix for this branch is going to be meth. Then, because it's a branch, a carbon branch, immediately after that prefix comes YL. So now we take that branch and then put it in front of the backbone name, and the name for the whole compound will be 4-methyl pentanoic acid.